see the unseen, change the unchanged. The innovation.
Hi, I'm geophysicist Ross Mitchell, and welcome to the video highlights of Volume 3, Issue 5 of The Innovation. The Innovation is clever to collaborate with professional artists for their eye-catching covers, and the cover of this issue makes that advantage bravely clear. We are now living in a parallel society. The rise of big data, artificial intelligence, and simulation technologies is changing how society develops. Close integration of real and artificial societies is the goal, and living within the metaverse is now within reach. Unfreezing our machines. Machines can grind to a halt when they become frozen over by ice. Anyone who's taken a plane flight during winter likely has experienced a delay as the plane sits on the runway waiting for the wings to be de-iced. But such minor inconveniences, if added up across different sectors of the entire economy, can add up to some serious decreases in industrial efficiency. Think of the major power outages in the United States last year as unexpected historic winter storm froze Texas wind turbines. And such extreme weather events are only more likely to occur more often due to global warming. Furthermore, many of the de-icing methods require manual operation in complicated and dangerous conditions. In short, current mechanical de-icing practices are neither efficient nor safe, and we need better anti-icing technology. Other anti-icing methods have been tried, including microwave, ultrasound, automatic robots, shape memory alloys, and even electromagnetic technology. But these methods for preventing ice growth are energy-consuming, costly, inefficient, or environmentally harmful. But no worries. In this issue of The Innovation, there is a new editorial to the rescue. The authors highlight a shift from de-icing to anti-icing. That is, instead of wondering how to melt ice after it forms on our machines, how can we prevent ice from forming in the first place? New technologies therefore focus on anti-icing strategies for suppressing water condensation, preventing ice nucleation, inhibiting ice crystallization, and reducing ice adhesion. I'll leave the details of innovative surface materials and self-lubricating aqueous layers to the authors. But suffice to say that none of these active or passive anti-icing strategies alone can meet the practical application requirements. Ideally, an effective anti-icing strategy in the future should combine the advantages of both active and passive methods. Ancient evidence for two-faced Mars. Earth is two-faced, with one hemisphere full of the continents and the other hemisphere containing the sprawling Pacific Ocean. Did you know that Mars is also two-faced? It's called the Martian crustal dichotomy, and just like Earth, the two hemispheres couldn't be any more different from each other. On Mars, the southern hemisphere is tall and mountainous, but the northern hemisphere is sunken and smooth. The crust of the southern hemisphere is thick and ancient, but the crust from the northern hemisphere is thin and young. But the Martian crustal dichotomy is ancient, and all of these features of it are only clues that come from Mars today. Are there any clues that can be found from early Mars? In this issue of The Innovation, a new report on which I am proudly co-author, my colleagues Zhang Lei and Zhang Jinhai have found such an ancient clue, and in a dramatic fashion too. One of the most fascinating geological features of Mars is the fact that the massive Hellas impact crater and the also massive Albopatera volcano are nearly positioned exactly opposite to each other. That is, they are said to be antipodal. The so-called antipodal effect is the idea that seismic energy from an asteroid impact on one side of the planet will travel around the world and get concentrated on the other side of the planet to cause a volcanic eruption. Prominent examples are known from Moon, Mercury, and Mars that are not complicated by plate tectonics like Earth. The Hellas impact crater and the Albopatera volcano is perhaps the best known example of the antipodal effect. But my colleagues noticed that something was slightly off. In fact, the crater and the volcano are 2 degrees offset from being perfectly opposite each other. or Antipodal. We conducted seismic modeling to explore what this clue was telling us. For some reason, the seismic waves from the impact traveled faster one way around the globe than the other. It was obviously telling us something about the Martian crustal dichotomy, but what? We found there was only one way to sufficiently explain the slight offset of the Antipodal effect. Different rock compositions of the crust on either side of the Martian crustal dichotomy was helpful but insufficient to explain the full offset. The only way to make the seismic waves travel at sufficiently different speeds was if there was different amounts of melt in the ancient Martian crust in the two hemispheres. Melt, which leads to the eruption of magma, can slow down seismic waves. More melt in the southern hemisphere is consistent with the southern highlands of Mars being more continent-like. This clue, the presence of melt on early Mars, cannot be measured today. It can only be found using the trick my colleagues and I used of understanding the Antipodal effect. But that's not all. In this issue of The Innovation, there are many other topics covered that we haven't discussed in the video highlights. Make sure to check them out. Topics include making sci-tech artwork from moon rocks, managing long COVID with biosensing, methane mitigation, insulating quantum materials, launch of a new module for the China space station, going beyond Hubble, ocean-negative carbon emissions, unlocking the secrets to human NTCP structure, opening up the black box of human cell plasticity, potential therapies for complicated autoimmune disorders, genomic surveillance for monkeypox virus variants, from organs on a chip to patient on a chip, cancer susceptibility genes, excess mortality rather than case fatality in assessing COVID-19, cartilage-inspired hydrogel lubrication, physics-aware training for machine learning, an AI roadmap towards the metaverse, coupling cyberspace and geographic space, optimization of artificial society, why are snakes cold-blooded, weight loss after fecal microbiota transplantation, sustainable development goals in Chinese cities, ultra-stable and superior electricity generation, single-cell RNA sequencing of COVID-19, coexistence of influenza A viruses and coronaviruses, metal organic frameworks for making hollow porous nanomaterials, and last but not least, wavefront shaping to conquer multiple scattering.
Pursue excellence.